Welcome back to the second part of this video series, and in this part we are going to create this circle and how to represent this on the circumference of this outer loop. Now, to understand this, we have to understand the basic mathematics behind how we are going to place this dot or this smaller circle over the circumference of this outer circle or the loop. We are going to use Pythagoras theorem to calculate the offset for this circle. Now, to get the basic detail about it, let's move to the whiteboard. So let's start. Let's learn the math behind how we can calculate the position of our circle. Now think of this. We have a square. This is our bounding box. That is, this is what we are going to give this size to this widget, whole widget. Now inside this there is a circle with touching it, and here in the center we have, now from here we give it a straight line. You will see the diameter of this circle is equal to side of this outer box. Now it is not very accurate, but now just think of, we have a ball which is siding circumference just here. Now what we want to do is calculate the x and the y position of this red dot on the outer circle. Now this outer circle is our loop and this red dot is our ball. Now from dot, if we give it a straight line to the dot, this dot, we will have an angle, let's name it A, and we will have this line segment which will have the same radius along all points on the circumference. And if we just get a straight line from the top to the base, we will have an height, and from here to this point we will have, that is, base. Now what we want to do is to calculate the x and the y of this point. To calculate it, let's think of that we are in a coordinate system which has a 0-0 center. So on the x-axis we have b. That it means if we find the b, we will find the x-axis of this dot, and if we find the h, we will find the y-axis of this dot, that is the y-coordinate. Now to use it, what we can do is, if we find the sine of angle A, we will have a height divided by radius. That is, this is the trigonometry. We use sine of A is height, that is the height which is the perpendicular side of a right angle triangle, by the hypotenuse, which is the largest side of a right angle triangle. For the cos part, we have cos of A is base by the hypotenuse, that is our radius in this case. Now since we don't have height and we don't have base, but we have angle A, since we are giving it to our widget, and we also have radius. So if we cross multiply it here and here, we will get the base would be equals to r multiplied by cos of angle A, and our height will be equals to r multiplied by sine of A. Since we know the base is also the x coordinate, so we found the x coordinate of our circle, that is this red circle on the circumference, and the y coordinate, that is our height, by this. So we got our x and also the y coordinate for our red circle. So let's go to the code editor again and code it from scratch. So here we are on our editor, and let's go to Painter and start and create another file, name it ballpainter.dart, and this time we are going to create another custom paint. So it should be named as ball painter, extends from custom painter, and let's decide some of the properties. So as in our explanation, what we have is a color for the color of the ball, and for the size of the ball, let's give it a radius, and for the angle at which this will be placed, so this angle is alpha in our demonstration video, so let's name it angle, and this will be angle. Now let's create the constructor. We have the constructor here. Now if we move down, we have to override two methods, that is paint and should repaint. Now for the should repaint, it is just when this painter should repaint its painting. So it should only happen when the previous widget and the current widget has different properties. Like if I have oldDelegate.color is not equals to the current color, or oldDelegate.radius is not equals to current radius, or if oldDelegate.angle is not equals to the current angle, only then this painter should repaint its painting. Now, since we already know that how we can calculate the x and y coordinate, let's make it x equals to cos of, now you can see that it wants a radian. Now we have a degree to radian converter that we created in our first video. Now we will pass the angle here and multiply it by the radius of the outer circle. Now the outer circle's radius is equal to the size by 2, that is half of the size. Now size.width divided by 2. This will give us the outer circle. Now we have to wrap this up in bracket so that we can follow the PEMDAS rule. Now y equals to sine of degree to radius, and we have angle inside it, so we will go out and multiply it by size.width divided by 2. Now we have our x and y coordinate. Bravo. Now see what will be the center of our red circle, that is the ball circle. Now what we can do is size, since we want to shift the center from 0.0 to that x and y coordinate for this painting. What we will do is size dot center so that we can shift it. Now we want the offset where we want to shift it. We will provide it an offset and provide the x and the y value so that the center can be shifted from 0.0 to x and y position. Now the final paths will be to create a path, that is just this path, and cascade it with now we want to create an oval. Technically it's circle, but we have an oval method which expects a rectangle in which this oval will be bounded. Now we have a rectangle dot from center that we can use. Now we can pass the center where we want to place this ball, and for the size we want to just get the size of this ball, which will be radius multiplied by 2. That's it. And for this one too, it will be radius multiplied by 2, so this will be the diameter of the ball. Now just format it betterly, and we will move down and give it a paint now. Now for the paint part, we don't need any extra thing, we only need color. Now we will provide it a color and just tell our canvas just to paint this. So here we are done with this ball painter. Now let's just test it whether it is working on. Now since we have passed the size to this custom paint, let's just move it to above and give it a size box of square shape and give it a dimension of 300, so that this custom paint and its all the child below will have a squarish size of 300 by 300. Now inside the custom paint we can give a child, and let's give it another custom paint and give it a painter, let's import it, give it a color of red, let's give it a radius of 10, and the angle would be like 60 degree. That would be good for our test. Now bravo, we have the circle on our outer circumference. Now we can just test it whether this is working or not. Let's just make it 270. That the end angle of the loop is our 270, and to get our ball at the end of the loop we can just give it an angle of 270. Now we have our ball painted. Now I guess we can move to the next part. So in the next part we are going to animate these two, so that if there is something change in the property, they should animate to that position implicitly. So see you in the next video. Bye bye.